the other day I was at my grandmother's house, and she needed some help going through a lot of paper that she's accumulated over the years. And so she invites me in the back, this little tiny extra room that she has in her apartment. And in the corner, she's got this small card table with a leatherette type cover. It still has the tag on it, and then about 30 inches of paper. Now, before RAID levels, my grandmother knew all about redundancy. She kept 3 copies of absolutely everything. 3 copies of her 1949 tax return, 3 copies of a random advertisement about glucosamine supplements. She kept 3 copies of everything. And she's going through the paper one by one by one. And I'm sitting there losing patience. And she comes upon this 1947 playbill of when she was in the freshman play at the University of Puget Sound and goes off on a tirade about how great that was. And I was in the play and everybody loved it. And then she puts it back. My grandma is a data hoarder. She used to be a librarian, and she really likes to hold on to information. She likes it around her because even though that playbill is not important right now, it might be important in a year from now, or maybe someday she might need to look at that 1975 tax return. You never know. Now, I'm sure everybody here has a family member who's a hoarder, who likes to hoard on to different things, and we say, oh, well, yeah, well, I don't do that. I get rid of all of my stuff, and I'm perfect. But I would argue that that's not necessarily the case. So if you've heard of inbox zero, there's a lot of people that go with inbox infinity, where you look over their shoulder and you see that they have about 8,000 messages and 3,000 of them are unread. Okay, so they don't read their messages. And so why are they holding on to this? And generally speaking, it's because of a compulsive hoarding feeling that we get, where we need to hold on to every bit of information as it comes through, just in case our boss asks us about that Nigerian bank account that we need to forward to him later. It's even worse in our own personal quirks. It's turned into an entire industry. I'm sure everybody here has heard of big data. It's amazing that we have 5 exabytes of data being created every 2 days. We have all this information. Everybody's connected on iPhones. They're connected on social media. They're connected on email, you name it. And we have all of this information. But I would say that this big data has really just become more of a big distraction. Unfortunately, if any of you have ever looked at the Twitter live stream as it comes through, most of the time it is total garbage. It is just the same people tweeting the same thing about Justin Bieber or Kim Kardashian or something in Portuguese that you can't even quite understand. So that gets us to the real point of this talk, which is, if we have all this information, that's great. But what's more important is figuring out the 20% of all this information that really, really outcomes for the 80%. If any of you have heard of the 80-20 principle, it's very simple. It's 20% equals the 80% output. I would almost go further to say that big data is kind of a 99-1% principle. So very quickly, I'm going to go over a couple techniques, which there are many techniques of seeing through the noise of the data that we have access to. But today, since our time is limited, I'm going to go through backwards induction, which is a game theory tactic to start with the end in mind and then work forwards. We're going to go over a couple different techniques for graphing in more than 3 dimensions. And then we're going to end with a very meaty portion, which is variable selection. So this is kind of a new topic, but it's using machine learning and classification trees to determine what variables are important and which ones aren't. So just a quick poll, who does TDD here? Okay. Who has ever had to explain to a boss why you should be able to do TDD? Okay. Now, personally, I've had this conversation a lot of times with business leaders saying, we really need to do TDD because we'll get the insurance. It's great because we'll have full code coverage, we'll have the ability to make sure that all of our tests are completely covered. But then they say, oh, well, that's going to take 30% more time, and I don't have that time. So then you have this conflict between long-term benefit and short-term cost. And so if you look up here, now this isn't necessarily a tree diagram, but they call it the bifurcation graph. It's a nice example in chaos theory of how things get totally screwed up. And the way I think about it is, if you start from the left, and if you make a decision and you say, should I go left or right? And you keep doing that on and on and on, then it just gets totally chaotic. Because if you've ever seen a tree that grows more and more, you'll get into these ruts. Now, going back to the TDD example, a business leader looks at it in the short term. So they're saying, okay, well, I have to spend more time, more money on testing. But the programmer is saying, okay, the long-term benefit is way better. And this gets us into the same thing that game theorists were dealing with, where you look at a game like chess, and realistically, what you want to do is you want to start 10 moves ahead, 30 moves ahead if you can do it, and then work backwards how to get to that move. So very simply, backwards induction is kind of thinking with the end in mind and then working forwards. So therefore, instead of saying, oh, well, we have this data, what are we going to do with it? Should we go left or right? It doesn't matter. You need to focus on the goal first. Now, I'm assuming most people here are probably using Rails, and they're building a web app of some sort. And I would say that in most cases, web apps kind of fall into the Dave McClure R metrics model. So if any of you have ever heard of Dave McClure, he runs something called 500 Startups, which was an incubator. And he came up with this idea that all metrics that are important fall into these 5 buckets. And it's easy to remember because you can just talk like a pirate whenever you feel like it. Quickly, it's acquisition, so user growth, activation, users doing something, retention, keeping them around, referral, and then revenue. Obviously, revenue is important. Now, if you know this, and you know where you're going, what you're trying to accomplish, then it's a lot simpler than just saying that we have the data, let's do something with it. It's more a question of saying, okay, I want to bring up users. I want more users and more acquisition. How do we get there? So very simply, I just threw some random ideas. It could be that spending more money, pay-per-click advertising, retweets about whoever you are, or the amount of times that you swear in a sentence, any of those things could mean more users. Now, it's a lot simpler than saying, we have Google Analytics, how do we get more users? You're looking at the goal first. And backing this out even further, you can say, how does pay-per-click advertising relate to growth in users? And simply, it's just graphing it out, looking at how the correlation goes together, and then saying, okay, perfect. Now, a quick side note, correlation, not causation. Just because I woke up in the morning and I drank a cup of coffee, that does not mean that I rose the sun from its horizon. It's just correlated. But unfortunately, correlation is most likely what you have to work with. Causation is kind of a qualitative measure. Okay, so another quick poll. Who likes Star Wars more than Star Trek? Okay, who likes Star Trek more than Star Wars? Okay, pretty evenly split. Who doesn't care? Yeah. All right, so most of you probably recognize this guy. If any of you have seen Star Trek Next Generation, this is Geordi LaForge, and probably one of my favorite characters of all time. He, also known as the Reading Rainbow guy, in case you don't know who this is. I think he's awesome because he's this guy who has this visor on his face, and he can see things that nobody else can see. So a couple episodes, he was looking at a bulkhead and said, "Oh, this has got a crack in it." Pretty cool, right? Plus, it's LeVar Burton, so if any of you did watch Reading Rainbow, I mean, that's kind of cool too, I guess. So this gets us into the thing of visualizing things. Now, most of the time, if you can visualize, then you can quickly disseminate information. That's really what's so great about visualization, is that you can see patterns. Our ability to recognize patterns is unparamounted. We're good at pattern recognition. But unfortunately, we cannot see more than 3 dimensions. We can see depth, width, and height. But there are some solutions to squeak out more dimensions. And those are very quickly color, tables, glyph plots, which I'll get into more a little bit later, and scatter plot matrices. So generally speaking, when you're working with lots of variables, it's a nice way to just start with tables. Tables are easy, they're easy to do. Start with tables. You're not visualizing anything, but it's there. And everybody knows how to use Excel. Now, as soon as you get past tables, then you can get into this color. So if any of you have ever used Crazy Egg, you'll notice this. This is a really awesome use of color where it tracks user clicks on the page and then aggregates it so that then you can say, this gets clicked a lot more, therefore people are interacting with it a lot more. And you can basically squeak out an extra dimension. So you could graph 3 dimensions with color on it. Kind of useful. Scatter plot matrices are also super, super useful. If you have more than 4 dimensions and you want to see how things are related to each other, scatter plot matrices, all they really do is they say, for each variable, I'm going to plot the 2D representation of that. So therefore, you're able to look at 100 different dimensions easily in a discernible fashion. The nice benefit to this is that you will also be able to see how variables like the x's are related to each other as well. So therefore, you'll be able to say that these 2 variables, while I thought they were different, are actually not. And the last one is probably my favorite. So it's the glyph plot, or in this case, Chernoff faces. So has anybody heard of Chernoff faces before? Okay. All right, so there was this guy, Chernoff, I think in the 70s, he was doing a study on judges and how people reacted to judges and how they thought about them. And the idea was he wanted to take, I think it was 12 different attributes of these judges and then map it to something that people could easily visualize. And he came up with something quite ingenious, which is using faces, which as human beings, we're able to recognize emotions in faces very easily. We can see when somebody's upset, surprised, angry, confused. And so he came up with a very intelligent way of putting together faces. Now, since this is Ruby conference, I figured that I might as well do an example of Chernoff faces. And if any of you are on your computers, which it seems like not very many are, you're welcome to take a look at the repo. It's just right up there. It's /hexgnu/Chernoff. So if any of you have ever worked with shoes before, shoes is a GUI tool. And it was started by Y Lucky Stiff, and it's really pretty awesome for making simple graphical user interfaces with pure Ruby code. So let me, can everybody see that, or is it good? Lots of audience participation on that one. All right, so very, very quickly, the Shoes app is just, this is very simple. I'm just going to create an 8x12 matrix of little turn-off faces. This face painter class right here is nutso. I just kind of quickly hacked a lot of this together, so please excuse the messy code. Really, all you need to know is that there is a variable for, let's see, head size, eyebrow slant, cross-eyedness, pupil size, eye width, eye height, eye area, nose size, mouth depth, mouth width, and smile. Very important variable. So running that, we get something like this. A bunch of smiley faces. Yeah, all right. And just to prove that I'm not making this up, I'll run it again, and there's more smiley faces and more. Now, of course, that's all fine and dandy. But what is the point of using turn-off faces, right? It seems like kind of a novelty thing that's kind of fun, right? Not really that useful. I would beg to differ. So there's a lot of companies out there right now, like Radian 6. There's another company, Sysomos Map, which do this sentiment analysis. So a lot of people are talking about sentiment analysis right now. And what they're doing is they're saying, for all of the textual data that's been talked about, is it positive, negative, or neutral? Now, if any of you know emotions and people well enough, you realize that emotions are not a one-dimensional problem. It could be negative, and somebody is very sad, angry. They could be ambivalent. There's so many ranges of emotion, and turn-off faces are really in a unique position of presenting that information quickly so that you could look at a face and say, the sentiment is this, not the sentiment is positive or the sentiment is neutral. So when I was at a startup in Seattle, we would get together every Monday in this tiny room. Every single Monday, we'd have a company meeting, all company meeting, every Monday. And at every Monday meeting, there would be the analyst who would get up for his 11.5 minutes. And he would talk about how we did last week and how we did the week before. But he didn't quite just talk about that. He talked about how we did page views, uniques, the standard deviation of the page views, standard deviation of the uniques. He'd talk about growth of growth. He'd talk about kurtosis, skew, a bunch of things that even me being a mathy type guy, I couldn't stand because I was just like, okay, that's great. I'm going to go back to work now. I really didn't care. Like, if he was talking about growth, why couldn't he just talk about how we did last week in terms of uniques, the week before, and what the difference was, and leave it at that? And that gets us into the next section, which is there are so many variables at our disposal right now. There are people who take text and turn it into a variable. You could say just about anything is a variable. But most of the variables aren't really that important. So in the case of this analyst guy, he would give us all of this information that really didn't impact how I was running or how I was working that day. And so we're going to talk about how to use classification trees to determine what variables are important and what aren't. Has anybody heard of a classification tree or a regression tree? Okay, a couple. So very, very simply, Here's an example that I stole off of Wikipedia. It's the example of the probability that you would survive from the Titanic. It's simple in that, are you male, yes or no? Are you over the age of 9.5, yes or no? And is your siblings and spouse greater than 2.5? Simple, right? Now, building these, there's many different ways of building classification trees. So there's bagging, which is short for bootstrap aggregating. There's boost trees. But my honest favorite is something called a random forest. Now, I always kind of get the idea in my mind that random forests are full of random deer and random mushrooms, but I don't know. Maybe that's why I like random forests. It was come up with this guy. This guy came up with it in 2001. His name was Leo Breiman, and it's interesting in that he was a PhD, super mathy guy. Then he went out and became a consultant, and then he went back to academia. So it's actually quite useful. And very simply, all it really does is it randomly goes through a big data set, creates these random trees, and then from all those random trees, it figures out which one has the most predictive power. Pretty simple, right? Now, there's lots of tools out there for making random forests. Python has one. Java obviously has one with Mahout. But also Ruby has one as well. It's called Nimbus. You can go to nimbusgem.org. It's primarily garnered towards the bioinformatics world and genetics, but it's actually quite useful, as we'll find out, in just using random forests. So I wanted to do another example, but this one a little bit more applicable. And really what I wanted to do is look at all of the tweets that I've ever made and figure out what factors, what variables are the things that determine whether I'm going to retweet something or not. So basically the idea is, out of all of the text that has ever been tweeted out of my Twitter account, which words are going to determine whether I retweet or not. So again, the code is up at GitHub. So if you want to look at it. Very quickly here, has anybody used the T-gem ever? If you haven't, it's a pretty awesome gem. It's just a very simple like command line interface to Twitter, and you can do really awesome things like, I just exported all of my Twitter, or all of my tweets that I've ever made into a CSV file. You can do other really awesome things, so quick plug there. From there, I just went through all of it, so sucked in all of the CSV, split everything up into different tokens, very simple tokenizer. I didn't spend a whole lot of time on this, and put it into a dictionary, which is just a sorted, all of the words that I've ever made sorted, so that therefore I can have like different variables. Running through all of this, created a training set, which is just a bunches of ones and zeros. So if you look at a row, it would be retweet 1 or 0. So if it's 1, that means that I retweeted it. If it's 0, that means I didn't. ID followed by ones for all of the words that I used. Now, after doing that, I had to create a config file, which is pretty simple, and then run Nimbus in this in the folder. Now, that took a long time to run, so I'm not going to run it right now. But what it did is that it created a classification tree. So, like, after you run Nimbus, and 15 minutes later, after you've had your coffee, it came back, and I was looking at basically a classification tree saying, these are the questions that you need to ask whether something will be retweeted or not. From that, though, gets into the question of which variables are more important than the other ones. So what text is more important? And so there's two ways of doing that in random forest land. One of them is called variable importance, or VIMP, a lot of people like to call it. And really what that is determining the sway of each individual variable on the actual end result. So it's a little bit complicated, and it's a little over my head in terms of what they're using for the statistics, but more or less from what I understand, it's really just that. It's how much a variable sways the end result. But I think an easier way of thinking about this is what they call minimum depth. So actually, if I back up here a little bit, you look at this classification tree, and the most important variable in this classification tree is gender, because it's at the very top. So if you think about how gender is the most influential variable, then you can say age is the second most, and siblings plus spouses, or, well, spouse, hopefully. Got to catch myself on that one. Spouse is the third. So it's a lot easier of a way to think about variable importance by just saying the most important variables are towards the top. Now, that's all fine and dandy again, but let's get to something that's really meaty. So what are the variables that determine whether I'm going to retweet something or not? And I just took the top 4, which all happen to be very specific people. So just to go quickly through this, the top guy is this management consultant who writes the funniest tweets, and I tend to retweet them. The second one is my wife. If I didn't retweet her, I would be sleeping on the couch. Third, Avdi Grimm, and Matt Might. If you don't know Matt Might, he's really pretty awesome too. Now, examples of the tweets that I retweeted. So I really like this one. I'm going to do a training. Really? On the way home, will you do a driving? I really hate the word training as a noun, by the way. Hitler was a micromanager. Yeah, I think that's funny. Everybody can probably relate to this one. Holy crap, all caps recruiter, do you have a job lead for me? And this one's actually interesting because it kind of relates to this talk in that more data does little good unless it becomes more information. So now that you're able to pick out which variables are more important than others, then you get into the real question of how this relates to what we were talking about before. So if you can say, okay, these variables are what's important, then I only need to really graph those. Or if these variables are important, those are the only ones that I need to work backwards from or try and model. Now, what's really interesting is there was a guy who is from University of Florida. His name is Hemant Ishwaran. I don't know the spelling, but he did a study about cardiovascular disease. And what was really interesting is that he was using the techniques that we were talking about here, and he had 310-ish variables. And after applying these techniques, he was able to take the 310 and turn it into 10. Now, that's huge because you're taking all of the noise out of what you're looking at. And if you're only looking at 10 variables, that's an easily visualizable thing that's something that you can wrap your mind around. So remember to start with the end in mind. It's so important when we have the amount of information that we have at our fingertips. Everybody has their phones, we have social media, we have email, we have IMs, we have text messaging. We have all of this data. If you don't start with a goal in mind, then you're going to end up completely lost. It's also important to figure out how you can visualize data. Because if you can visualize it and you can conceptualize it, then you can understand it a lot easier. And lastly, classification trees are super, super useful for determining what variable is more important than the other one. And it's very simple to conceptualize how the ones at the top are more influential. And so if I was to leave you with one thing, and one thing only, remember to not be like my grandmother and not hold on to data, because it's not really important how much data you have. The important thing is what you do with it. Thank you.